Hello and welcome to today's chemistry class. In this class, we'll do a quick revision on chemistry, right, for the JAMB and WAEC examination. So look at how to solve this particular question here, and so we get. Question says, how many unpaired electrons are in the p orbital of a fluorine atom? Option A, I have 1, 2, 3, and and 0. So let's solve number one, please. Number one solution. Solution to number one. I'm saying that how many unpaired electrons are in the p orbital of a fluorine atom? First, our fluorine is atom number what? 9. If fluorine is that atomic number 1, I mean what? P orbital. So I'll go here and draw the if you can recall very well, the SPDF configuration. Either you start drawing out 1s, 2s, 2p, 3s, 3p, 3d. So without wasting our time here, let's use this one. This one is still okay. We said a left hand slant, a left hand slant, a left hand slant. So for this one, we're having 1s, 2s, 2p, 3x. This is for 9. This is beyond 9 even. So now I'll first write out the SPDF configuration for fluorine. So for fluorine there, my SPDF, the SPDF of fluorine is given as 1x squared, 2x squared. This is 4 out of 9. Left with what? 4 out of 9. Still left with 5, Abi. So I have p to the power 5. 2p to the power what? 5. This is what? 4 plus 2 plus 2 is 4 plus 5 is what? 9. So this become the SPDF configuration of fluorine. But we're going to find what? They said how many unpaired electrons are in the what? P orbital. So I have to draw the orbital of this fluorine. So we said let's do a staircase on, right? We can do it in a straight form of staircase. So for the p orbital, so I have start with this. A box contains maximum 2 electrons. This one s squared, 1x squared. So that's for this. For this one here, let me use it small. That'll be space. This is for 2x squared. Next up, I have this one. This is for 2p to power 5. So this is 1 to this way. This is 2 electron. So I'll fill up the upper one first. 1, 2 electron for this one. This is what? 2. Upper one, down one. 5 electron. Upper one, upper one, upper one. This is 3. Down one, down. This is 1, 2, 3, 4, 5. So how many unpaired electron? How many unpaired electrons are in the p orbital of what? This is p orbital of fluorine. That's just what? Just 1 unpaired electron. So my answer here is what? Just 1 unpaired electron are in the p orbital of fluorine atom. That's number 1. Let's do number 2. Number 2 says calculate the percentage composition of oxygen in calcium tricarbonate 4. Now your ability to solve this is that, can you write out compound? I've do a video on how to write compound, how to name compound. So your first things first, for you to fill this question now, is that can you write compound? If you can't write it, you fail this man, because they expect you to write compound here, and from that compound you should get the percentage composition of what? Of oxygen. Now number 2 solution. Question number 2 solution. Said calculate the percentage composition of oxygen. I know that in what? Calcium tricarbonate 4. I have calcium. Calcium is 2 plus what? Combined with what? Triocarbonate 4. That's CO3, right? 2 minus triocarbonate 4. I have 2 minus. If I combine these two, we said when two elements can only combine if they are what? Opposite charges. This plus and minus, they can combine, but they have the same power. 2 they will cancel out, so it becomes Ca CO3. The compound is called calcium terrazocarbonate 4. This is a compound there. I'll write this compound first. After writing out this compound now, CaCO3, they expect you should know how to write this. So this is what they gave us from the question. And now this is the compound here now. If you want to understand this concept very well, go and watch our video on how to name compound using the concept of valency. I've done the video. I'll drop the video in the description of this video. So try to watch the description of this video. Check the description of this video. You see a video that will take you to or a link that will take you to how to write compound. All right, at this point now, let's get the percentage composition of flow of oxygen. We said when it comes to percentage composition concept, the idea there is that for percentage composition, I'll be considering just an element. So go and recall that for percentage composition, percentage composition of an element is equal to the mass of that element we are told to find, right, all over the relative molecular mass of the compound. So you have to record this, please. Now let's get this done, please. First, I need to get my relative molecular mass of the compound. So let's get it, please. At this point, calculating for relative molecular mass of the compound. What's the compound there? I have CaCO3. Calcium is what? 40. That's 40 plus carbon is 12. That's 12 plus oxygen is what? 16 times what? 3. This is what? 40 plus 12 plus this 48 here. Add them together. I'll have it should be about 100 gram per mole. This is what? 100 gram per mole. This is my calculated relative molecular mass now. So I cannot get percentage composition. So let me call PC as being percentage composition of what element? Of oxygen. Of oxygen is equal to mass of elements. What's element I'm considering? Oxygen. What's the mass of oxygen? 16. Now that becomes 16. But mind you, oxygen has 3 moles here. That's times 3 all over relative molecular mass of the compound. That's what? 100. I have 100 here. So times what? 100%. Please always this is times 100% here, please. Oh, 100%. All right, let's get this done, please. By the way, this one we cancel this, right? So if I multiply 16 by 3, multiply this, we cancel this, right? 16 by 3 we give 48. So my answer there becomes a 48%. So this one says calculate the percentage composition of oxygen. So it is what? 48% as the percentage composition of oxygen. This becomes your percentage composition of oxygen has been equal to 48%. See you in the next class. Do it to like, hit the subscription button, leave a comment, and share to your friends and classmates so they can learn too. See you in the next class.